Hello everyone, and welcome back to the video lecture series on rational expressions. So for this next video, we are going to be taking everything that we have learned so far about adding, subtracting, multiplying, and dividing rational expressions, and we are going to be combining them all into one problem, and those are called complex fractions. So complex fractions are going to combine everything that we have learned about all of the operations on rational expressions into one single problem. So a complex fraction will look something like this. There is an overall fraction here, and in either both the numerator and the denominator, or just one of the other, but in one or both parts of the fraction, there is either addition or subtraction. So there is addition and or subtraction kind of built into the overall fraction, and it looks something like this. Now, the trick with complex fractions is you are going to simplify both first and last. You are going to try and simplify as you go. So just do yourself a favor, and as you go, if it looks like things can be simplified, such as combining like terms, distributing, you're going to go ahead and do that. This way you are not overwhelmed with simplifying at the end of the problem. Now, in expressions like these, if you remember from order of operations, you might have seen something similar to this, but probably a little less complicated. There are no parentheses here that we can see, but there are implied, hold on. There we go. But there are implied parentheses around both the numerator and the denominator. So what you have to do is you actually have to perform any addition and or subtraction first before you go worrying about the overall fraction. Now, this fraction bar that's right here in the middle can be thought of as division, and it is going to follow all of the same rules as dividing regular fractions. So what you will do is you will combine both the numerator and the denominator into one single fraction. You're actually going to add those together to create one single fraction in the numerator. Then you are going to subtract those two fractions to create one single fraction in the denominator. Remember, when you add or subtract fractions, you need common denominators. Then, once you have one fraction in the numerator and one fraction in the denominator, you are going to follow all of the same rules of dividing rational expressions. You are going to leave the top fraction alone. You are going to change the division to multiplication, and you are going to flip the bottom fraction. So after the addition and subtraction has been done, you're going to do a keep, change, flip. Keep the top fraction alone as is, change the division in the middle to multiplication, and then flip the bottom fraction. So here are the overall steps to simplifying a complex fraction. You need to do the adding or subtracting first. And remember, to add or subtract, you need common denominators. And you are going to try and simplify as much as you can now. This way you're not overwhelmed at the end. So then, once you have done all of that, now that you have one single fraction in the numerator and one single fraction in the denominator, that fraction bar in the middle can be thought of as division. So step number 2 is you are going to divide the two fractions. You're going to keep the top fraction as is. You're going to change that division in the middle to multiplication, and then you are going to flip the bottom fraction. Now that it is written as multiplication, then what you're going to look for are, can I factor anything? And now that it's written as multiplication, you can cross-reduce. So you can cross-reduce as soon as you rewrite that division as multiplication, and then all of the same rules of cross-reducing apply. You're going to factor everything that you possibly can, and cancel out common factors between any of the numerators with common factors in any of the denominators. So we're going to take a look at this first complex fraction. So this fraction bar right here that is in the middle, we can think of that as the division. And we're going to do the division in a little bit. First, we're going to take care of that subtraction in the numerator and that addition in the denominator. So remember, if you want to turn a whole number into a fraction, you can do so by putting it over 1. So I'm going to put that 9 over 1. And then I'm going to do the same thing with the 3. So you basically have two separate problems where you have to find common denominators. So looking at 9 over 1 minus 4 over x squared. We need to find the common denominator between 1 and x squared. Well, the common denominator between 1 and x squared is going to be x squared. So I'm going to multiply this first denominator by x squared. Then whatever I do to the bottom of a fraction, I need to do the same thing to the top. And that's it. I don't need to multiply that second fraction by anything in order to find common denominators. Then I'm going to do the same thing on the bottom with this 3 over 1 plus 2 over x. I need to find a common denominator between 1 and x. So the common denominator between 1 and x is x. So I'm going to multiply this first denominator by x, and then I'm going to do the same thing to the top. And that's it. I don't need to even touch the second fraction. They now have a common denominator. So that will give us x squared times 9 is 9x squared over x squared minus 4 over x squared. Then on the bottom, x times 3 is 3x over x plus 2 over x. Now resist the urge to cancel anything out. Remember, the whole point of that was so that you could find common denominators and do that addition and subtraction. So on the top here, I'm going to carry over that common denominator of x squared. Then I'm going to subtract the numerators, and because the second numerator only has one term, I don't need to worry about distributing the minus sign. So I'm just going to take the first numerator, 9x squared, and I'm going to subtract the second numerator, 4. Then on the bottom, I'm going to do the same thing. I'm going to carry over that common denominator of x, and I'm just going to add the numerators, 3x plus 2. Now that we have one single fraction on top and one single fraction on the bottom, now we get to take care of this division in the middle. So we are going to take this top fraction and we are going to keep it. So we are going to leave it alone as is, 9x squared minus 4 all over x squared. Then I'm going to change that division in the middle to multiplication. And then I'm going to take this bottom fraction and I'm going to flip it. So I'm going to flip the bottom fraction, which will give us x over 3x plus 2. Now that it is written as multiplication, now we can think about cross-reducing, so we can start to factor anything that looks like it can be factored and start to look at common factors that can cancel out. So 9x squared minus 4, 9 is a perfect square, 4 is a perfect square, and they're being subtracted. This is a difference of squares. So to factor 9x squared minus 4, that is going to factor as 3x plus 2 times 3x minus 2. Then the denominator x squared is not going to get any better than that. And then there's nothing to factor in the second fraction, but what I am going to do is I'm going to put parentheses around that 3x plus 2 in the denominator. And now I'm going to start looking at common factors. Remember, this x in the numerator, where the glitch was, has an exponent of 1. So the obvious one is 3x plus 2 can cancel out with 3x plus 2. Now these standalone x's do count as common factors. Remember, this x squared here in the denominator can be thought of as x times x. So this x in the numerator can cancel out with one of these x's in the denominator. And remember, they don't go away when they cancel out, they simply become 1. So let's multiply what's left over. So what's left over in the numerators, we have 1 times 3x minus 2 times 1 is 3x minus 2. And then in the denominator, x times 1 gives us x. So 3x minus 2 over x is going to be your final answer. So that's going to be the overall idea anytime that you have a complex fraction. You need to do the addition and or subtraction that's on the top and the bottom first. Then once you have a single fraction on top and a single fraction on the bottom, then you can keep, change, flip. Keep the top fraction, change the middle division to multiplication, and then flip the bottom fraction. So taking a look at this next one, we have 1 plus x over, plus 1 over x plus 1 half, We're going to find common denominators between them. So since the two denominators have no common factors, the lowest common denominator is simply going to be their product. So I'm going to multiply this x by 2. Whatever you do to the bottom, you need to do to the top. Then I'm going to multiply this 2 by x, and then whatever we do to the bottom, we need to do to the top. Then in the denominator, on the bottom here, we're looking at x squared and 4. So we need to find a common denominator between x squared and 4. Now there's no common factors, so the lowest common denominator is simply going to be their product. So I'm going to multiply this x squared by 4, and then whatever I do to the bottom, I'm going to do to the top. Then I'm going to multiply this 4 by x squared, and then do the same thing to the top. So then I'm going to do some simplifying. So 2 times 1 is 2 over 2x. Then plus 1 times x is x over 2x. Then on the bottom, we have 4 times 1, which is 4, over x squared. And then minus 1 times x squared is x squared over 4x squared. Then I'm going to do the adding and subtracting. I'm going to do the adding in the numerator, so I'm going to carry over that common denominator of 2x, and I'm going to add the numerators together, 2 plus x. Then on the bottom, I'm going to carry over, sorry, that is a 4x squared. On the bottom, I am going to carry over that common denominator of 4x squared, and I'm going to subtract the numerators. Now, because the second numerator only has one term, I don't need to worry about distributing that minus sign. So I'm just going to take the first numerator, 4, and subtract the second numerator, x squared. Now that I have one single fraction on top and one single fraction on the bottom, now I can take care of this division of fractions. So I'm going to keep the top fraction as is, 2 plus x all over 2x. Then I'm going to change that division in the middle to multiplication. And then I am going to flip the bottom fraction. So when we flip the bottom fraction, we're going to get 4x squared all over 4 minus x squared. Now that we have multiplication, now I'm going to think about factoring anything that looks factorable and canceling out common factors between the top and the bottom. Remember, there is multiplication between that 4 and that x squared, so both the 4 and the x squared are considered factors. Then there's multiplication between the 2 and the x, so the 2 and the x are also considered factors. So 2 plus x doesn't look like that can factor any further, but I'm going to leave it alone, and I'm going to put parentheses around it. And then 2x, again, it's not going to get any better. Then in the numerator over here, again, 4 times x squared, not going to get any better than that. But the denominator, 4 minus x squared, we have a subtraction of two terms. 4 is a perfect square, and x squared is a perfect square. So this is a difference of squares. This can actually be factored as 2 minus x times 2 plus x. Same format as you normally would factor a difference of squares. So now let's go looking at common factors between the top and the bottom. The obvious pair is the 2 plus x's. Those can cancel out. Then the x's here, so this x in the denominator can cancel out with one of the x's here. And then, yeah, 4 over 2, since 4 and 2 are both factors, they can cancel out. So 2 divided by 2 is 1, and then 4 divided by 2 is 2. So now that we have simplified everything that we possibly can, let's multiply what's left over on the tops and multiply what's left over on the bottom. So we have 1 times 2 times x is 2x. All over 1 times 2 minus x times 1 is 2 minus x. And remember, with multiplication of fractions, as long as you are careful to fully cross-reduce at the beginning, you will not have to do any cross-reducing at the end. So for this next one, if you take a look at the bottom fraction, the x plus 3 over 4, notice that this is already one singular fraction. So they've already gone ahead and added together the fractions on the bottom, so we don't have to do anything to the bottom yet. But in the numerator, I have addition of two separate fractions, so I'm going to have to add these two fractions together by finding common denominators. So I'm going to find a common denominator between 2 and x. Since they have no common factors other than 1, their lowest common denominator is simply going to be their product. So I'm going to multiply this first denominator by x. Then I'm going to do the same thing to the top. Then I'm going to multiply the second denominator by 2, and then do the same thing to the top. Now remember, this entire time, I'm just going to leave the x plus 3 over 4 alone, since that's already one fraction. And I'm going to focus on the top. So x times 1 is going to be x over x times 2 is 2x. Then plus 3 times 2 is 6 all over 2x. So let's add together those fractions on top. So I'm going to carry over that common denominator of 2x, and I'm going to add the numerators x plus 6. Then on the bottom, I still have this x plus 3 all over 4. Now that we have one singular fraction in the numerator and one singular fraction in the denominator, remember this fraction bar in the middle here can be thought of as division. So I'm going to keep the top fraction as is, x plus 6 all over 2x. Then I'm going to change that division in the middle to multiplication. And then I am going to flip the bottom fraction, which will give us 4 over x plus 3. Now there's not much in the way of simplifying to do here. Remember, this doesn't factor and this doesn't factor, and they are not common factors, so no, do not cancel out the x's. Those are common terms, not common factors, and common terms don't count. You can also not reduce the 6 and the 3 because notice how they are being added. Those are common terms. Common terms cannot be reduced. However, because this 2 is being multiplied by this x, and this 4 up here is just by itself, the 2 and the 4 are common factors, so you can reduce the 2 and the 4. So 2 divided by 2 is 1, 4 divided by 2 is 2. And that's really it. So let's multiply what's left over in the numerators. So I have x plus 6 times 2. And then in the denominator, I have x times x plus 3. And yes, it is completely okay to leave it like this. I'm fine with that because, again, we simplified as much as we could at the beginning, so we're pretty much done. If you want to distribute the top and the bottom, you can. So if you distribute that 2 in the numerator, you get 2x plus 12. And if you really want to distribute that x in the denominator, you get x squared plus 3x. I don't really care which one you give me. So either one of these is perfectly acceptable. So this next one is going to be a little bit more involved. So again, the division is actually right here in the middle. So the division is actually this middle fraction bar right there. So that is going to be our division, which means, the top is kind of a mess, but on the bottom we just have this 3n. So we'll tackle that 3n in a little bit. I do have to worry about doing that addition on the top first, which means that I do need common denominators. Now we're finding a common denominator between n minus 2 and n plus 1. They don't have any common factors, so because they have no common factors, the lowest common denominator is simply going to be their product. So I'm going to take this n minus 2 and I'm going to multiply it by n plus 1, and then I'm going to do the same thing to the top. Then I'm going to take this n minus 1 and I'm going to multiply it by n minus 2, and then whatever you do to the bottom, you need to do the same thing to the top. So let's simplify as much as we can. So again, remember I've got this over 3n, which I'm going to deal with later. For the first fraction, I'm going to leave the denominator alone, so we have n plus 1 times n minus 2. And then I'm going to distribute the 5 to the n plus 1, so that'll give us 5n plus 5. Then I've got that plus sign in the middle, and I'm going to do basically the same thing for the other fraction. I'm going to leave the denominator alone, n plus 1 times n minus 2, and I'm going to fully distribute the numerator. So n times n will give us n squared. N times minus 2 is negative 2n, minus 1n is negative 3n, and then negative 1 times negative 2 is positive 2. Then I'm going to carry over that common denominator, and I'm going to add the numerators together. Don't forget, we've still got this over 3n here. So I'm going to carry over that common denominator of n plus 1 times n minus 2. And I'm just going to add the numerators. Now, since I am adding, I don't need to worry about subtracting about distributing any negatives. So I'm going to take the first numerator, 5n plus 5. And I'm going to add to it the second numerator, n squared minus 3n plus 2. And while I'm at it, that numerator is kind of a mess, so I'm going to combine some like terms, and I'm going to write it in standard form. So again, I still got this over 3n, don't forget about it. That common denominator that we had is still going to be there, n plus 1 times n minus 2. And I'm going to combine some like terms. So I'm going to list the n squared term first. Then 5n minus 3n is plus 2n. And then 5 plus 2 gives us plus 7. So now that we have one single fraction on the top, and technically we have one single fraction on the bottom, so I'm going to just turn that 3n into a fraction by putting it over 1. This fraction bar in the middle can be thought of as our division. So I'm going to take the top fraction and I'm going to keep it as is. So n squared plus 2n plus 7 all over n plus 1 times n minus 2. Then I'm going to change the division to multiplication, and I'm going to flip this bottom fraction, which will give us 1 over 3n. And unfortunately, there's really no simplifying to do, because n squared plus 2n plus 7 doesn't factor. There are no two numbers that multiply to 7 and add up to 2. So because this doesn't factor, there's no common factors to cancel out at all. So I'm just going to multiply the two numerators together. So all that times 1 is n squared plus 2n plus 7. And I'm just going to mush together all of the denominators with multiplication. So 3n times n plus 1 times n minus 2. You do not need to distribute that. That is as good as it's going to get. So for this next one, we're going to do basically the same thing. Remember, the division here is this fraction bar in the middle. So that fraction bar right there in the middle is actually our division. So first thing I notice is that I have some whole numbers in here. Remember, you can always turn a whole number into a fraction by putting it over 1. So I'm going to put the 2 over 1 to turn it into a fraction, and the 1 over 1 to turn it into a fraction. And we have two separate addition and subtraction that we are going to do first by finding common denominators. So on the top here, I'm finding a common denominator between x minus 4 and 1. So the common denominator between x minus 4 and 1 is going to be x minus 4. So I'm going to multiply this 1 times x minus 4. Then whatever we do to the bottom, we're going to do the same thing to the top. And I don't even need to do anything to that first fraction because they will already have common denominators. Now on the bottom, I'm finding a common denominator between x and 1. So the common denominator between x and 1 is going to be x. So I'm going to multiply this 1 by x, and I'm going to do the same thing to the top. And I don't even need to do anything to that first fraction. They will have a common denominator. So on top, we've got x squared over x minus 4 plus 2 times x minus 4. I'm going to distribute the 2, which gives us 2x minus 8. All over 1 times x minus 4 is x minus 4. Then on the bottom, I have this 2x minus 2 all over x. And then minus 1 times x is x over x. Now I'm going to actually do the adding and the subtracting. So I'm going to carry over that common denominator of x minus 4. And I'm going to add the two numerators, which the first numerator, x squared, plus the second numerator, 2x minus 8. Then I'm going to do the same thing on the bottom. I'm going to carry over that common denominator of x, and I'm going to add I'm going to subtract the numerators. And I'm also going to kind of combine like terms as we go. I don't have to worry about distributing any negatives since the second numerator only has one term. But, I do see that there's a couple like terms there. So 2x minus x is going to give us x minus 2. Now that we have one single fraction on the top and one single fraction on the bottom, now I am going to do the division. So I'm going to take the top fraction and I'm going to keep it as is. So I'm going to keep the top fraction, x squared plus 2x minus 8 all over x minus 4. I'm going to change this division here in the middle to multiplication. And I'm going to flip that bottom fraction, which will give us x all over x minus 2. Now that this is multiplication, we're going to look for anything that can possibly factor, and I'm going to think about trying to cross-reduce and cancel out common factors. So x squared plus 2x minus 8 can factor. There will be an x here and an x here. And we're looking for two numbers that multiply to negative 8 and add up to positive 2, which are plus 4 and minus 2. And then the x minus 4 in the denominator is not going to get any better. Then nothing really factors in the second fraction, but I am going to put parentheses around the x minus 2. Now that we have factored everything, that we can cancel common factors across multiplication. So this x minus 2 cancels out with that x minus 2, and that is really it. So from here, I'm going to multiply the two numerators together, which will give us x times x plus 4. All over, remember that became 1. X minus 4 times 1 is x minus 4. And yeah, you can leave it like that, that's fine. If you want to distribute the numerator, you will get x squared plus 4x all over x minus 4. I don't really have a preference. So for this next one, this is another example where if you take a look on top, the top is just 3/5. So there's only one single fraction on top, so we don't have to worry about the top right now. But if you look on the bottom, we have 2 over x plus 4x over 3. This is, a complex fraction, so we are going to have to do that addition first. So for now, I'm just going to leave that 3/5 on the top just completely alone, and I'm going to focus on finding common denominators on the bottom. So I'm trying to find a common denominator between x and 3. Because they have no common factors other than 1, their lowest common denominator is simply going to be their product. So I'm going to multiply this x by 3, and then whatever you do to the bottom, you do to the top. Then I'm going to multiply this 3 by x, and then I'm going to do the same thing to the top. So 3 times 2 is going to give me 6 over 3x, plus 4x times x is going to be 4x squared, all over 3x. Now I'm actually going to do that addition on the bottom. Remember, I'm just going to leave the 3/5 alone for right now. I'm going to carry over that common denominator of 3x, and I'm going to add the numerators together, which will give us 6 plus 4x squared. Remember, this fraction bar here in the middle, that is our division. So I'm going to keep the top fraction as is, 3/5. I'm going to change that division in the middle to multiplication. And now I am going to flip the bottom fraction, which will give us 3x all over 6 plus 4x squared. And then from here, there's really no simplifying to do. Yes, 6 and 4x squared do have a common factor of 2, but even if you factor that out, it doesn't cancel out with anything in the numerator, so you don't have to. So let's just multiply the two numerators together. 3 times 3x is 9x. And then, put parentheses around this because both denominators are going to be multiplied. We have 5 times 6 plus 4x squared, parentheses. Which, this is fine. If you want to distribute the 5 in the denominator, you can to give you 30 plus 20x squared. You don't have to do that. This is good enough as a final answer. So then for this last one, it's going to be basically the same idea. I see, a bunch of subtraction on the top and some addition and subtraction on the bottom. This fraction bar that is in the middle here, that is our division. So I'm going to do the subtractions in the numerator and the addition and subtraction in the denominator. Remember, when you have addition and subtraction performed together, you're going to do them in the order that they appear when you read the problem from left to right. So the first thing I'm going to do is I'm going to turn each of those whole numbers into fractions by putting them over 1. And I'm going to focus on finding common denominators between all 3 fractions in the numerator, and then another set of common denominators between all 3 fractions in the denominator. So taking a look on the top, we're trying to find a common denominator between 1, x, and x squared. Now, since the first two denominators, since the last denominator is simply just a multiple of the first two, the common denominator between 1, x, and x squared is simply x squared. So I'm going to turn all of these denominators into x squared. So I'm going to take this 1, I'm going to multiply it by x squared. Whatever you do to the bottom, you have to do to the top. Then I'm going to turn this x into x squared by multiplying it by x, and then I'm going to do the same thing to the top. And this third fraction I don't have to do anything to because it already has our common denominator x squared. Then I'm going to do the same thing on the bottom. I'm looking for common denominators between 1, x, and x squared. So the common denominator between 1, x, and x squared is going to be x squared. So I'm going to take this 1, I'm going to multiply it by x squared, and do the same thing to the top. Then I'm going to take this x and multiply it by x. Then I'm going to do the same thing to the top, and I don't have to do anything to the third fraction to get a common denominator. So after you do the multiplying, you're going to get x squared over x squared minus 2x over x squared, then minus 15 over x squared. Then on the bottom, you're going to get x squared over x squared minus 11x over x squared, and then plus 30 over x squared. Then on both the top and the bottom, I'm going to do the addition and subtraction. So on the top, I'm going to carry over that common denominator of x squared, and I'm going to subtract in the order from left to right. And since none of these numerators have more than one term, thankfully I don't have to worry about distributing. So I'm going to take this first numerator, x squared, I'm going to subtract the second numerator, 2x, then I'm going to subtract the third numerator, 15. Then on the bottom, I'm going to carry over that common denominator, x squared, and I'm going to do the same thing. Since the subtraction comes first, I'm going to do that first because I do the addition and subtraction in the order that they appear from left to right. So since the subtraction goes first, I'm going to do that first. So I'm going to take the first numerator, x squared. Then I'm going to subtract the second numerator, 11x. Then I'm going to add to it the third numerator, 30. Now that we have one singular fraction on top and one singular fraction on the bottom, that middle fraction bar is our division. So I'm going to keep the top fraction as is, x squared minus 2x minus 15, all over x squared. I'm going to change that middle division to multiplication. And I am going to flip the bottom fraction. So I'm going to take this fraction on the bottom, and I am going to flip it over. It gives us x squared all over x squared minus 11x plus 30. So now that we have written this as multiplication, now we can think about factoring anything that looks factorable, and we're going to think about common factors. Remember, these standalone x squareds here are factors. So I'm going to then factor x squared minus 2x minus 15, and I'm going to factor x squared minus 11x plus 30. Since I'm running out of room, I am going to need to do that on the next slide. So factoring x squared minus 2x minus 15, there's going to be an x here and an x here. Two numbers that multiply to negative 15 and add up to negative 2 are plus 5 and minus 3. And don't forget we had that x squared here. Then, in the numerator of the second fraction, I have this x squared. And then I'm going to factor that x squared minus 11x plus 30 in the denominator. So there's going to be an x there and an x there. And I'm looking for two numbers that multiply to positive 30 and add up to negative 11, which are minus 5 and minus 6. So now we're going to cancel out any common factors between any of the numerators and any of the denominators. So x minus 5 cancels out with x minus 5. The x squareds can also cancel out because remember, anything divided by itself is 1, so these x squareds can cancel each other out. Now for the x plus 3 and the x minus 6, I don't care that they have an x, that they both have an x. Those are common terms, not common factors. Because these two sets of parentheses are not exactly the same, you cannot cancel them out. And you cannot reduce the 3 and the 6 because this 3 is being added and this 6 is being subtracted. You cannot cancel out or reduce across addition or subtraction, only across multiplication. So let's just multiply what's left over in the numerators. 1 times x plus 3 times 1 is x plus 3. Then in the denominator, 1 times x minus 6 is x minus 6. And then that is going to be our final answer. So that last problem is about as complicated as these are going to get. So all complex fractions are going to follow pretty much the same process. Find common denominators to do the adding and subtracting first. Then you're going to keep the top fraction, change the middle division to multiplication, and flip the bottom fraction. So these type of problems do combine everything that we have learned so far in this rational expressions chapter, and so these problems do take a little bit longer. So make sure that you are managing your time effectively and working on the 6-4 homework gradually. So thank you all very much for watching, and I will see you guys in the next video.